Hello friends and welcome back. Now before we jump right into this lecture, I do want to give you a friendly heads up that we are going to be doing things like flashing lights back and forth in both the scene and the game view. So if you're susceptible to things like seizures or light sensitivity, please do be aware that we are going to have some flashing lights in this lecture. In this lecture, let's take the first steps to adding some additional 2D lighting to further enhance the way our scene looks. And what better way to do that than with a muzzle flash at the end of our gun? Now we have a couple different options on how to create a muzzle flash. We could use something like bloom. We could use a modified sprite of some kind. But I think what's going to give us close to the effect that I'm looking for is just a 2D light that we can toggle on and off at the base tip of the gun. So let's open up our player model, open up our visuals, open up our gun, and then right-click our gun to create an empty game object, and let's call that the Muzzle Flash game object. On this game object, let's add a 2D light component. So search for 2D light and add a 2D light component, and I'm going to keep that as a spotlight. I'm going to position this right at the end tippy top of my gun, and we can just barely see it here currently at the tippy top of my gun. So let's modify some of these properties, but all we're really trying to do is through our script, we're just going to toggle this on and off every single time we fire a bullet to give us a nice little and subtle muzzle flash. To make sure that we can see this a little bit better, I'm actually going to find my global light 2D, and I'm going to turn that down just a tad so we can see everything a little bit better and add some ambiance to our scene. So I think like something around 0.78, 0.8, something around there is going to be about right. Because we're going to be adding some additional lights soon, let's create an empty game object in our hierarchy, and I'll just call it lights for now. We'll just drag in our global light so we know where to find it, and shortly we'll add a whole bunch more. Let's go back to our muzzle flash and adjust some of these properties here. I don't want too much intensity, so something around 1 is probably right. We can adjust that shortly. I'm going to ramp up the way my inner circle fills to something around 0.7, 0.8, something around there, and then actually adjust my outer quite significantly to make sure that my flash actually gets shown on some of the tiles, the background, and my player sprite directly. So I think something around 9 or 10 is probably going to be about right. Now I am going to adjust the fall off strength pretty close to the tippy top since I don't want any sort of harsh lines, so I think something around maybe 0.7, 0.8 looks about right. Now we're not going to get into casting shadows or anything like that at the moment. That's a bit out of the scope of this course, at least currently. So I'll go ahead and just minimize these for now. You know what? I think that looks about right. Let's go ahead and set it to inactive by default, open up our gun class, and we can go ahead and adjust the settings that we need properly. And if I remember, we already have this nice on-shoot action event, and we can just subscribe to it with a muzzle flash. So what are we going to need? Well, we're going to need a serialized field for that muzzle flash. So let's create that as a private game object so we can just toggle it on and off. We'll call that our muzzle flash. And let's create another one for a private float so we can signify the time for how long we'd like it to flash. So private float, and let's just call that the muzzle flash time. And let's go create that private method, probably just right at the bottom. And we'll call that our private void muzzle flash with a capital M. And all we want to do is go into our muzzle flash and set it to active. And let's set that to true. And all we want to do is wait a specific amount of time before we toggle that back off. I think a coroutine is just a fine way to do it. So private IE enumerator, we'll call this coroutine the muzzle flash routine method. We'll go ahead and yield return new, wait for seconds, and then just pass through that muzzle flash time that we created as a property up top. And we'll set it to inactive. So muzzle flash.setActive is now false. Now, one thing that's important is we want to make sure that we're only firing one coroutine at a time. If we set our serialized float fire time for how quickly we can fire bullets to something incredibly quick, we might actually get some confliction with how many coroutines we have and toggling them on and off, So we probably want to cache this coroutine to something specific so we can toggle it to off as necessary. So up at the top, let's create a private coroutine, and we can just call this the Muzzle Flash routine. That way, when we start the coroutine to it, we can actually cache that value to that reference. So instead of just starting the coroutine normally, let's set the Muzzle Flash routine equal to start coroutine. The Muzzle Flash is the coroutine we'd like to start. So we probably want to make sure that it's not already running. And if it is running, we just want to stop it. So with that reference, we can actually now say, if the Muzzle Flash routine is not null, then we just want to stop that coroutine. So stop coroutine. Which coroutine do we want to stop? The Muzzle Flash routine. And this is perfect, but I think it probably makes a bit more sense to just start and stop it in the routine directly, even though the logic is the exact same. But I think that looks quite nice. Now all we need to do is subscribe our Muzzle Flash method to the onShoot event. So let's go ahead and just duplicate these two lines. I'll just copy and paste it there, and now we're properly subscribing and unsubscribing to our onShoot event that we already have rigged up. So I think the last thing we want to do is just decide how long we want our Muzzle Flash time to be set to. Now, I'm not exactly sure, but something around just a split second of maybe 0.05 is probably going to be about right. Let's go see what that looks like back in Unity. Let's click our gun game object, drag our Muzzle Flash into our gun. I'm also realizing we still have this console log. We don't need that anymore, so I'm just going to go ahead and double click it, delete that debug.log line, and then we'll go try that out back in Unity one more time. Nice. I think that's giving us close to the effect that I'm looking for. Now, that might be a bit too bright. It almost kind of feels like it's going to cause me some sort of seizure or something like that. So I'm going to ramp that intensity down, maybe just a tad, to something like 0.75 looks about right. And then maybe I don't want it to flash even quite as long as that. So I'm going to click my gun and change my Muzzle Flash time to something like 0.02 seconds, which is probably a frame, maybe something along those lines. And you know what? There we go. I think that looks pretty good. You can adjust that as much or as little as you'd like, depending on how it looks good to you. But for now, I'm pretty satisfied. Well done on this lecture. When you're ready to move forward and continue introducing some 2D lighting into our scene to make our scene really come alive, I'll see you on the next lecture. In this lecture, let's continue introducing some fun lights into our scene with this colorful spotlight. To do that, let's create a spotlight prefab that we can use and just attach all over our scene. So in our sprites folder, I believe it's found in environment, we have this nice already pre-spliced up spotlight. So let's go ahead and start rigging up our prefab. Let's go ahead and just call it spotlight. And in here, I'm going to go ahead and create another empty game object for our visuals just for organization. And then once again in here, two empty game objects. I'm going to call one the base. I'm going to duplicate that, rename it with F2, and then I'm going to name that one my head. On both of these, I'm going to add a sprite renderer. On the base, let's go ahead and add this base sprite, and on the head, let's go ahead and add the head sprite. Nice, and just like that, let's make sure this is zeroed out appropriately. And then what I'm going to do is just to get it positioned correctly here, I'm going to click my spotlight, hold Control to make sure it's moving while snapped, and then I'm just going to position one right here on the middle and the bottom left of our screen tad. Now on our head directly, let's go ahead and right-click and create a 2D light. So let's navigate into Lights. Spotlight 2D is what we're looking for, so I'll go ahead and create that. Now, we don't want it just a full 360-degree radius. I'd like it pointing in this specific direction like you'd imagine a spotlight would. So I'm going to ramp up my intensity just so we can see everything a bit more clearly. And let's start angling this appropriately. So I'm going to stretch out my outer length to something like around 15, 16, even though it might look a bit dramatic for now. My inner is going to be, I don't know, something around there. We can adjust it shortly. But then let's start angling this to make sure we're getting it in the right direction. So I'm going to put it to something like there and, oh, I don't know, maybe something around there, but I'm going to shrink in my inner angle quite a bit. I want quite a bit of fall off strength. I don't want any too harsh of lines. I think something around there looks pretty good. Let's just make sure we're angling it in the right direction. So I'm just going to grab my Z rotation and just make sure we are angled roughly in the right direction. Maybe something like there, and then we just need to do a bit more adjusting. So I think the outer is way too high. Inner is probably still a bit too strong. I'm going to take my inner radius and just stretch it out just a tad. And I think that looks about right. Now, the one issue we're having is this targeting sorting layer is actually being displayed on my lamp directly. Now, I don't really want that, so let's create a new sorting layer so that our lights don't affect that specific sorting layer. So I'm going to go into my target sorting layers. Nope, not quite. I need to go into my layers, add a layer, and in my sorting layers, not my layers, I need to create a new layer called No Light. And I'm going to make sure that is displayed below my VFX sorting layer. So I'm going to drag my No Light to layer 2, and my VFX layer will now be layer 3. With that selected, I tend to like to use a sorting group on my visuals game objects in my hierarchy, so I'm just going to go ahead and do that for both my base and my head. So if I add this sorting layer of No Light to it, we can just always make sure that our base is rendering below our head, because we're going to get this rotating back and forth shortly, so I don't want any sort of clipping on my sprites. So I'm going to go into my head sorting layer, and even though this says default, because it's a child of our visuals game object that has the sorting group of No Light on its sorting layer, these will indeed actually display on that No Light sorting layer. So it doesn't really matter, but just for visual representation, I'll go ahead and change this to No Light as well. Next, we can actually go into our Light 2D, go into our target sorting layers, and then just make sure that our No Light sorting layer is not being affected. Ah, perfect. Now, I actually had this bug just a second ago, but I think I know exactly what to do and why it's being caused. This is more of actually just a Unity bug than anything. So, because the way that sorting layers and layers are being adjusted in Unity, if you go into this layer sort of setting, we shifted the way that our sorting layers were adjusted, and I think that has to do something with the underlying bit mask value of the way that these sorting layers are represented. So because we switched from layer 2 to layer 3 of our VFX file, it actually still thinks that our VFX is still under that layer 2 value, I think. And I think that's what's going on, because if we click our Light 2D and you unclick our VFX, well, then it's actually not getting displayed properly, which is kind of close to what we need. So I'm going to restart Unity, and we're going to see if that actually fixes the issue. Okay, nice. I just restarted Unity, and it actually does indeed look like it fixed my issue. That actually took me a second to debug before I started recording, so I'm glad that got fixed. I'm going to go back into my Light 2D and then just shift it down a bit. I don't think that's quite exactly angled where I'd like it, but something around there looks about right. And we can even do a bunch of fun things like change the color. So just to kind of give us a visual representation, maybe something nice, like a nice bright purple ought to look pretty. Now let's actually just make our spotlight a prefab. So let's go into Assets, Prefabs. Let's create a new environment folder. Go into Folder and create Environment. I can never spell that word right. And let's just drag in our spotlight. With that created, let's just place a few more around the scene. I'm not going to go too overboard, but I'm going to go ahead and duplicate it. Drag one maybe over here, I think looks about right, kind of towards the center. And then I'm actually just going to flip mine directly. So is that my Y rotation? Yep. And then let's create one more. So I'm just going to place one more maybe in the other direction, maybe over here. So we don't want to flip the Y direction. I think we actually want to flip the Z direction. 180. Yes, and then I actually do want to flip that as well. What does the X-axis do? Ah, yes. We could have used that. We probably could have done that the other way around, but I think that's just fine. So let's navigate our spotlight down just a tad to be right there. And you know what? I changed my mind. Let's actually make sure our spotlights are displaying behind the default layer. So I'm going to go into my layer settings, add layer, even though we're not adding a layer, and then I'm just going to drag my no light layer to be behind my default layer. But we might actually have to restart Unity again. I wish there was a better way to do that. I feel like it might just be a bug with Unity 2023. I'm gonna go ahead and restart Unity one more time. Now there might be a better way to like reset my cache or something along those lines, but let's move forward. I'm gonna go ahead and drag my spotlights into my environment folder, but let's organize this a tad. So I'll create empty, we'll just call it pipes, and we'll drag all of our pipes inside here because eventually we'll probably want some more. And again, let's create another empty called spotlights, and we'll drag all 3 of my current spotlights in here. Just to spruce up my scene a tad, I'm going to change the lighting on my other 2 lights to give a nice visual representation of where we're going. So let's just change this. I'm not going to think about it too much. Maybe a nice green. And then this, maybe a nice blue. Ah, yes, that looks quite nice. All right, well done. We've got our spotlights set up pretty close to how we're looking for. On the next lecture, let's actually get our spotlights moving, rotating around. And if we want to change the color as well, we can do that in our script. When you're ready to move forward, I'll see you on the next lecture. In this lecture, let's create some fun logic to get our lights oscillating back and forth using the mathf.pingpong method. To do this, in our scripts and miscellaneous folder, let's go ahead and create a new C# script. And let's call it Color Spotlight. I think from memory why I called it Color Spotlight and not just Spotlight from when I was prototyping is because just calling it Spotlight I think conflicts with the 2D lighting namespace. So really all we're looking to achieve is oscillating this light back and forth. I'm going to adjust a couple things in my editor to improve my quality of life. I'm going to go ahead and hide my gizmos for a moment, as well as disable some of the things that we can click in the scene. For example, I don't need to be able to click my screen space canvas, don't really need to be able to click my grid. Now I think I can just go ahead and click my spotlight directly. Ah, that's nice. So what we're really trying to achieve is something in script that if we go into our visuals and in our head directly, we just want to be able to oscillate it back and forth like this, so we just need to oscillate our Z value here. So I'll go ahead and Control Z that, and let's go ahead and open our Color Spotlight script in VS Code. Now there's a couple different ways that we can oscillate it back and forth. I think the most simplest and most intuitive way to set that up is using the mathf.pingpong method. So let's go ahead and grab a serialized field for the head of our spotlight. So private game object, and let's just call that the spotlight head. Now you could probably even do this in something like a coroutine. I'm just going to go ahead and do it and update directly. I think that's just fine. So I'll go ahead and create a private void rotate head method. And let's go ahead and just call that an update every frame. So rotate head. Now because we're doing this in update, we're going to need some way to cache our current rotation value up top so we can adjust that over time. So let's create a private float called current rotation. Let's make sure we spell that right. And in rotate head, let's just change that current rotation according to time.delta time and some speed variable that we can set up top. So plus equals time.delta time finds a rotation speed float that we haven't yet created. So let's call that rotation speed. And I'll just go ahead and highlight that. And if I press Control and dot, we can go ahead and click Generate Field for Rotation Speed. Except I do want to serialize that just in case we want to change that value in the inspector. Let's go ahead and set it to something like 20F to start, I think is reasonable. And back down in our rotate head method, let's create a float Z float directly in rotate head. And we'll set that equal to mathf.pingpong. So what do we need to take in? We need to take in 2 different floats. The first one being our current rotation, and the second one being for a max rotation that we'd like to oscillate to at the max amount. So let's call that the max rotation, and we haven't created that yet either. Let's do the exact same thing. I'll highlight that, Control dot, and we'll generate a field called max rotation. I'll make sure I serialize that as well, just in case we want to change it in the inspector. And I'm going to set that to 45 degrees. I think that makes a lot of sense to kind of give us something that's half of a 90-degree angle and rotate that back and forth. Next, all we need to do is actually rotate it according to those values. So spotlight head dot transform dot local rotation equals quaternion dot Euler, and then we can just plug in those x, y, and z values. So 0f for x and y. We don't want to rotate those, but we do want to change our z value, so we'll just plug in that z float that we just declared. Nice, let's go try that out and see what it looks like back in Unity. On any one of our spotlights, let's go ahead and attach that color spotlight class. Let's make sure we drag in the head visual, and then just apply it to the prefab so they all oscillate together. Let's click play and see what that looks like. Nice, we've got it ping-ponging back and forth exactly 45 degrees. I think that already looks quite nice. Now, one thing that bugs me just a tad is that they're all oscillating at the exact same time. If we had something like 20 different lights in our scene and they were all oscillating together, I don't think that's going to quite be the variation I'm looking for. So I think that's going to introduce us to this lecture's challenge nicely. Well, let's get you pointed in the right direction on what we're looking to accomplish. Let's create a private void, random starting rotation method. And all we're going to do is call that directly in start. So let's go ahead and do that. Random starting rotation. Nice. With that naming convention set up, let's introduce you to this lecture's challenge, which is going to be create some logic in our random starting rotation method so that each of our spotlights starts with a random starting rotation within our bounds so that they're not all oscillating back and forth at the exact same time. There's definitely a few different ways you could go ahead and rig that up, so I think it makes a great challenge. Pause the video, take a moment, give it your best effort, and I'll see you back here in a few moments. All right, welcome back. The way that I'm going to do that is with initializing a float directly in random starting rotation, and we're just going to call that the random starting Z. I'll go ahead and set that equal to random.range, and then I'd like to choose somewhere in between our negative max rotation and our max rotation. So I'm just going to go ahead and copy this. It's going to be very, very similar. We'll just go ahead and copy that, but we'll pass through this random starting Z value instead. Next, all we need to do is modify our current rotation up top to be equal to our random starting Z plus our max rotation. Nice, let's go see how that feels back in Unity. Let's click play and give it a whirl and keep your eye on these three spotlights to see if they randomly choose their starting rotation. And yes, it looks like we're set to go. When you're ready to move forward to the next lecture, I'll see you there. In this lecture, let's add a disco ball to the scene, something else that can interact with our bullets, and let's talk about how powerful interfaces can be when implementing something like this. Let's set up something else in our scene view that we can actually interact with our bullet. So I'm going to go ahead and create an empty game object that I'll just call disco ball. And on here, let's add a few different components that we can work with. First and foremost, let's add a sprite render just so we can see what we're looking at. And let's add this disco ball sprite that you can find in your sprites folder. I'll go ahead and just zero this out briefly. And we'll just position this into space on somewhere where we can actually see it and interact with it on our bullet. So holding Control, I'm just going to shift it on over to this top right corner of this tile map kind of over here. Now, what else do we need? I'd like it to flash when we hit it with our bullet so that we can interact with it. So let's go ahead and do that. I'm going to hit this little lock button, head on over to my materials folder, and I believe in our textures folder, we can go ahead and add this white flash material as well as our sprite lit default material. Next, let's go ahead and add a circle collider to it. Let's just zoom in so we can see what we're working with. And shift this radius down just a tad. I think that's about right. We'll go ahead and shift the offset up as well, and I think that gives us something to work with. And I'm going to go ahead and toggle on the is trigger property. And that's it. We don't want it to take damage. We definitely don't want it to get knocked back. However, something like that might actually be cool if it was hanging from a string or something like that. But we do want to create its own unique C# script, so we'll go ahead and do that in our scripts. Let's just put it in our miscellaneous folder. Let's right click, create a new C# script, and we'll call it the disco ball script. pause for a second, briefly take a minute to actually see what we're trying to accomplish. We want both our disco ball and our enemies to actually collide with our bullets when they take a hit from the bullet. One way that we can achieve that very gracefully is with the implementation of using an interface. So in our scripts and combat folder, let's go ahead and create an interface, and we can briefly talk about what that means. Let's create the hittable interface. And we'll go ahead and let that compile. Now, just as a reminder, an interface is basically like a contract. You can implement as many interfaces on a class as you would like. Interfaces can even implement other interfaces, and it's essentially just a contract to that specific class saying, hey, you have to implement these specific functions. So let's open up our hittable interface and actually see how we do that. We can actually just hit Control-A to highlight everything, delete it, we don't need any of that. And we would just like to create a public interface called hittable. In here, we can declare as many members as we would like to make sure our contract enforces. In this case, we just want to implement a void take damage function. Now, inside of an interface, we don't really need or even really want to declare this as specifically private or public, because in our case with the public interface, because this is a contract, we can't actually declare this as private. It will always just be public. And let's actually see what this looks like. Let's go over and open up our enemy class as well as our new disco ball class, and we haven't done anything with it. Now, in our enemy class, we can just right after mono behavior, type hittable. If you highlight it and press Control dot, it will give you this prompt in VS Code to implement that interface. I believe that does it at the very bottom, and voila, we have now implemented our contract. Well, let's go ahead and do that in our disco ball as well. So in our disco ball, same thing, hittable, and then let's go ahead and Control dot to implement that interface. And let's just go ahead and for whatever reason that spawned it at the top, let's just put it at the bottom as well. And for now, let's just go ahead and delete these start and update methods. And let's work our way over to our bullet class. So it's about time that we get this cleaned up, because we don't necessarily want our bullet to only interact if it has health, if it has knockback, if it has flash. It would probably make a lot more sense that if we had a dozen different things that wanted to interact with our bullet, well, let's actually just check if it has the hittable interface. So let's go and use some of that same syntax, and we can say hittable, and then let's just call it hittable with a lowercase h, and then we'll just check if it has that hittable. And then we can just check if any of the components on it implement the hittable interface. So we can just say other.gameObject.getComponent hittable. And then we can do the exact same thing. So hittable question mark dot take damage. Looks like I've got a little typo here. I'll just go ahead and delete that caret, put a period, and we're all set to go there. And let's actually talk about a couple different ways that we could go about implementing this interface. Like all things code architecture, there's a couple different ways we could go about approaching something like this. So I'm going to actually lead us down a path that's not going to be our final result as an example, but let's talk about it. First and foremost, we don't need anything here. But let's actually, in our take damage hittable contract, let's take through those two parameters that we might need. Number one being an int for a damage amount and a float for knockback thrust. We'll go ahead and pass both of those through in our hittable take damage function. So because this is a contract, we actually need to do that in both now our enemy and our disco ball. So let's go ahead and do that. Let's say int damage amount and float knockback thrust. Let's just go ahead and copy these values here, and we'll head on over to our disco ball and do the same. Now over in our bullet class, we just need to pass those through. So for now, let's just pass through the damage amount and the knockback thrust float. Now in this case, we have a little bit of what's referred to as a code smell. Our disco ball isn't actually going to need to do anything with damage amount or its knockback thrust. So I don't really think this is the best way to go about doing this. So one thing that's nice about interfaces is an interface can actually implement an interface. So in the case of our disco ball, we really only want it to flash. So let's go ahead and make sure we just grab that component. We'll call it private flash with an underscore and lowercase f. And in awake, let's just go ahead and grab it. So flash equals get component flash. Now we already have that set up. So let's just go ahead and call flash.start flash. And you can see that we're not actually using this damage amount or the knockback thrust. So to me, that feels a little icky. But let's go ahead and move forward for now, and then we'll come back and refactor it in a moment. In our enemy class, we're actually going to need all of those components that we originally were handling in the bullet directly. So let's just go ahead and cache those values up top. We're going to need knockback. We're going to need a flash component, so let's go ahead and grab that as well. And last but not least, what else am I forgetting? We're going to need to grab the health component. So private health underscore health. And then we'll just grab all of those in awake, albeit a bit tedious. So knockback, get component, knockback. And then let's see if I can just duplicate these two lines, and then we'll be nice and fancy with our copy paste. So grabbing our health component and just making sure all three of those references are grabbed in awake as needed. So down on here in our enemy take damage, we just want to go into health and take damage. I think we called it take damage. Nice. And we can pass through our damage amount. That's great. We can go into knockback, and then we can also call knockback.get knocked back. What do we need? We need the direction. So player controller.instance.transform.position. I think that's just how we had it before, as well as that knockback thrust float. So nothing fancy there. Last but not least, we also can call flash. I guess we'll go ahead and do that for now. I'm hesitating because this isn't actually the way that I want to do it, but for now, let's just go ahead and call start flash. All right, and with no compilation errors, let's actually just head into Unity and see what that looks like. Before we hit play, let's just go ahead and make sure we add the disco ball class. Let's hit play and see what that looks like. So if we fire, nice, our slimes are still being knocked back. They still take damage in the die. Everything looks good there. And if we hit our disco ball, nice, we have that nice little flash mechanic. Now everything is working as intended, but I'd like to go refactor the way that our iHitable interface is actually passing through some of those parameters. Now we're not necessarily wrong by any means, we're just passing through some parameters we're not using. So let's create another interface, and let's call it iDamageable. And let's go ahead and open that up. We just need to create a public interface called iDamageable. And one thing that's really cool about an interface is that it can implement other interfaces. So we can just say iHitable. So instead of having our take damage function inside of our iHitable interface, let's actually just cut that out entirely and place that into iDamageable. In iHitable, let's have a void take hit function that doesn't actually take anything in. This way, when we go to our enemy, if we actually scroll to the top, we don't necessarily want to implement iHitable. All we need to do is implement the iDamageable interface. Let's go ahead, highlight that, press Control period, and implement the interfaces that we're missing to fulfill that contract. So if we scroll down, we now have this take damage function, beautiful, and we have our take hit function. I'm just going to go ahead and slide down my flash into my take hit function. And take damage, I think it makes sense to both take damage and to get knocked back, since we're not really going to have one without the other. In our disco ball, all we need to do is now implement the iHitable contract, which I believe is called take hit, and we don't need this take damage function at all. In here, all we want to do is flash it. So underscore flash dot start flash. And that's all we want to do. Now heading on over into bullet, we could just go ahead and kind of copy paste this. It's pretty similar. So let's just refactor this. In iHitable, all we need to do is take hit. It doesn't pass anything through. And then down here, in iDamageable, we can go ahead and rename that as such. All we want to do now is take damage. And we just want to make sure we're getting the right iDamageable component. So go ahead and pause there, make sure all that syntax is right. That was a bit of a tongue twister for me. But we're now set to go. Now, it doesn't actually look like we refactored much. We really only got rid of 2 lines. Now, this is a bit more of a game feel course, so we're not going to be implementing 24 enemies or anything like that. But I hope you can actually pause, take a moment, and see the power in what we just did. It would now be very easy to have an explodable barrel or an explodable box or different types of enemies or different types of ways that our bullet could interact with things that have hittable. But it doesn't necessarily want to take damage. It can now also interact with things that specifically want to take damage and get knocked back. You could even implement an high knockbackable interface as well. That might even actually make more sense, but for now, I'm pretty satisfied in the way that we have this set up. So let's head back into Unity and see what that looks like. So we've got our disco ball flashing, we've got our enemies being hit and taking damage properly, so we do have the exact same result. However, I do quite like that refactor, and I hope you can actually see the power of implementing interfaces correctly. For now, let's move on, and when you're ready to move forward to the next lecture, I'll see you there. In this lecture, let's make it so that when we hit our disco ball, we have a little disco ball dance party and move all of our colored spotlights, dim the lights, and eventually listen to some music as well. To do that, in our scripts miscellaneous folder, let's go ahead and create a new C# script, and I will call this the disco ball manager. In our hierarchy, let's go ahead and create a new empty game object, and I'm actually just going to call this managers. And inside here, let's go ahead and create another empty game object, and let's call this the disco ball manager. Let's go ahead and drag that on in and open that up in VS Code. The way we're going to set this up is every single time we hit a disco ball, and we'll have multiple disco balls in our scene, we're going to go ahead and create and fire a new action called onDiscoBallHit that we can fire from other classes as needed. So let's go ahead and create that. Let's just create a private static action, and we'll go ahead and call that the onDiscoBallHit event. And let's go ahead and import the using system namespace. Go ahead and fix that typo there. What we'd like to do is subscribe a few different things onto this onDiscoBallHit event. I think in this lecture we're only going to do one, but eventually we'll subscribe a few different things as well. For now, we just want to create a function called dim the lights. So private void, we'll call it dim the lights. And that's going to do a couple different things for us. It's going to go into each individual spotlight and speed that rotation up as we saw in the preview, as well as dim our global light intensity. So with that empty function created, let's go ahead and subscribe to our onDiscoBallHit event. So let's create an onEnable and an onDisable. Let's go ahead and type onDiscoBallHit event. We'll subscribe our dim the lights function, duplicate it, slide it down, and then let's also just unsubscribe from it, so changing that to a minus sign. So what do we want to do here? We want to go into each individual spotlight and then just increase that rotation speed for just a few seconds. So let's create that few seconds as a serialized field. So serialized field, I'm going to go ahead and make it a private float, and we'll just call this the disco ball party time. Let's initialize it to something small for now, just for testing. And let's go ahead and grab all of those spotlights. So private color spotlight, I'm going to go ahead and grab it as an array, and I'm just going to call it all spotlights. And let's grab those in start. So once again, good rule of thumb, handle start, grabbing other things, awake, initializing yourself. So I'm going to go ahead and grab and look for all of those spotlights to set them into the array. Now there is a little bit of a gotcha. In Unity 2023, they did actually change the way we use find objects of type. It's now no longer find objects of type, but objects by type, as well as, instead of just find objects by type, color, spotlight, you do actually need to pass through a little bit of additional logic and specifically set the sort mode. So objects, sort mode, none. So find objects, sort mode, none. That way when they go into the array, they're not going to be sorted necessarily. And we do actually have to pass through that additional logic. If we don't, we actually do get a compilation error. So with that basic skeleton set up, let's actually make this your lectures challenge. Inside of our dim the lights method, go into each individual color spotlight and increase their rotation speed for the duration of disco party time. And then after that, go ahead and reset it back to its default rotation speed. Pause the video, give it an honest effort, and I'll see you back here in a few moments and we'll go through it together. Alright, welcome back. So inside of Dim the Lights, I'd like to create a for each loop, and I'd like to modify each individual spotlight. I'll just call it Spotlight with a lowercase s, and where am I doing this? I'm using the collection of all spotlights. So in Spotlight, let's go ahead and open that up. And I would like to create a public IE enumerator to make sure we're using a coroutine for that wait time. And I'm just going to call it the Spotlight Disco Party. And we'll pass through that float for the wait time. So disco party time. We need to make sure we first cache a float for the default rotation speed. So we'll just call that the default rot speed. And we'll set that equal to the rotation speed. Now we want to actually set that rotation speed to something a little bit faster. So I'll go ahead and copy that. We'll just call it the disco rot speed. And we'll change that to something significantly faster, so something like 120. And now we want to actually change that rotation speed to our disco rot speed. We then want to yield return, new, wait 4 seconds, and then we just want to pass through that disco party time. Once that time has elapsed, let's go ahead and set our rotation speed back to our default rot speed. With that function set up, let's head back into our Disco Ball Manager and then call that in each individual spotlight. Except we need to start the coroutine, so let's go ahead and do that. Start coroutine, spotlight. Looks like my IntelliSense is not working. This is the issue I was talking about before. I bet we even imported the global illumination namespace. We definitely don't need or want that. We just want to make sure we're setting this to the color spotlight. Now, I think we should have that IntelliSense working perfect, the Spotlight Disco Party. Sorry about that. And we want to pass through the Disco Party vote time. Nice. I think the only thing we need to do now is fire this on Disco Ball hit event. Now, I'm actually going to create this as a public function directly in our Disco Ball Manager. So let's go ahead and create it right below on disable. Let's create a public void. We'll just call it the Disco Ball Party. And we'll go ahead and fire that event. What did we call it? The on Disco Ball hit event. And we'll just go ahead and invoke it. Inside of any old disco ball, once we take a hit, let's just go ahead and grab that reference for our Disco Ball Manager. We'll call it Disco Ball Manager. And we'll go ahead and grab that and awake, except we want to use Disco Ball Manager. We just want to go ahead and find object of type Disco Ball Manager. I'm going to have this gotcha a million times for a while. So once again, in Unity 2023, we don't actually use find object of type. I think this would actually work. It's just giving us a warning. So it has been deprecated. We now need to use find first object by type instead. That'll get rid of that warning. Then we just want to go into our Disco Ball Manager and then fire that public method. What did we call it? Disco Ball Party. Let's head back into Unity and see where we're at. Let's create a couple different disco balls in our scene just to make sure everything is working correctly. I'm just going to go ahead and put it up here, even though we can just barely see it in our game view. That's just fine. And I'll go ahead and in the environment, let's go ahead and create a new empty game object. We'll call it Disco Balls. And we'll go ahead and drag in both disco balls just for organization. Feels like I'm forgetting something. Let's see. We've got our Disco Ball Manager. We got our Disco Ball time. Great. Let's go ahead and hit play and see what that looks like. Perfect. 1, 2 seconds, and let's see if they reset. Perfect. That's great. Now we do have a little bit of an issue. We're not caching the coroutine or anything like that, so I think we're going to have a little bit of some unintended logic or mechanics if we spam our bullets on the disco ball. We now have a bunch of different coroutines all going at once, so let's head back in and create some additional logic to make sure that we can only fire one coroutine at a time for our disco party. While we're there, let's also adjust our overall global light intensity. So you can see here somewhere where we can find our lights, our global light 2D, I think it'd be kind of cool if for that brief moment of our disco party, later on we'll also fire some additional music, but it'd be cool if we also literally dimmed the lights. In other words, dimmed this global light intensity. So let's do that as well. Let's head back into our disco ball manager. To grab a light 2D, we need to import the using unityengine.rendering.universal namespace. That way it'll let us grab a serialized field for that 2D global light. So private light 2D, and let's just call that our global light. Let's also make sure we cache that coroutine so we can only fire one at a time. I'm going to drag my event above my serialized fields, and then we'll create a private coroutine, and let's just call that the disco coroutine. Down here, let's create that coroutine that we're going to be able to use as a private IE enumerator, and let's call that my global light reset routine. In here, we just want to go into our global light and set the intensity to something specific. So let's actually go up here and create one more float. Let's call this the disco global light intensity. Let's set it to something like 0.2. I think that was about right when we were looking in the inspector and experimenting around. Let's have another float that we don't need as a serialized field, and let's have it be our global default light intensity. So private float, default, global light intensity. We don't need that as a serialized field because we can just cache that on something like awake. And in awake, we can just set our default global light intensity to be equal to our global light dot intensity, since it also has that nice read value that we can get. Now with all of those floats set up, we can go directly into our global light reset routine. We can first set our global light intensity equal to that disco global light intensity float. Then we just want to wait a few seconds equal to our disco party time. So yield return, new wait 4 seconds, disco party time, and then we want to set our global light intensity back. So global light dot intensity equal to our default global light intensity. After that, we just want to make sure that our disco coroutine is set back to null. So where we start this coroutine, we can actually just do it and dim the lights directly. We want to start a coroutine, but we want to make sure that we set that reference to our disco coroutine. So we want to set disco coroutine equal to start coroutine global reset routine. That way, when we have our disco party, that is not what I wanted to name it. Let's just rename it as disco ball party. So I'm going to go ahead and just make sure I'm renaming that globally. So disco ball party, even though I kind of like disco party, I think that would probably work just fine. But let's go ahead and just make sure that coroutine is null before we fire this event. So what do we want to do? We just want to go check if disco ball routine, not disco ball routine, disco routines. We just want to make sure our disco routine, if it's not set to null, in other words, it's running, then we just want to return. Nice. Let's head back into Unity and see what that looks like. On our disco ball manager, now we can just grab this global light 2D, drag it in. Let's hit play and see what that feels like. Nice. We've got it dimming for a couple seconds. And then even perhaps more importantly, I think we've only got one coroutine going at a time. Yep. That whole thing only lasted 2 seconds and it never actually got reset. We should be able to hit both disco balls as intended without any getting sort of confliction. I'm just going to go ahead and make our disco ball party time something a bit more reasonable, like 5 seconds. And I think we're set to move on. Well done on this lecture. When you're ready to move forward, I'll see you on the next one.